Okay, so we've been talking a lot about mixtures and solutions this semester so far. So let's start by talking about what the difference is. We know that a mixture is just two or more things mixed together. So I think of trail mix. You can see there's usually peanuts, raisins, M&Ms all mixed together in one bowl. That's an example of a mixture. You can see all the different parts that we mix together. When I think of a solution, I know that a solution is a mixture formed when one or more substances dissolve into another. When I think of the word dissolve, I think of the process of a substance becoming incorporated uniformly into another. My mind automatically goes to salt water. We know that when we put salt into water, the salt dissolves, it spreads out uniformly throughout the water, and it makes a solution. We can't see the salt anymore, but we know it's there. When we think of solutions, we know that solutions have two parts, a solute and a solvent. A solute is a substance that dissolves in a solvent to form a solution. In this case, the salt would be our solute. As for the solvent is a substance in which a solute dissolves to form a solution. So in our case of salt water, that would be the water. It's what takes in all that solute and helps distribute evenly throughout. So now that we know what a mixture and a solution is, we need to talk about what we do to separate them. Way back in the beginning of the school year, we talked a lot about how we would have many things in a bowl or in a cup and how we were going to separate them into different parts. So we'd have all the different parts separated together. One way we can use to separate things is using a filter. That would be like the coffee filter paper we've been using with the funnel. Filter is usually used to separate small particles from water or a different type of liquid that would run through it. We also know that we've used a screen, which is that wire mesh piece that's used to separate larger objects like gravel from our mixture. We've also used magnets to help separate things that are magnetic. We've used the magnet to attract them and pull them out of a mixture. And last but not least, if we have something like salt and water together, we can use evaporation to help us separate the salt from the water, and then we get to see the really cool salt crystals left over after. Models. We had a whole section about models. Do you guys remember the black box models that we used? We created them. We had to study them. Well, models is an explanation or representation of an object, system, or process that cannot be easily studied. Models are used to help us understand things that are sometimes really difficult to understand. Scientists make models. You and I can make models. Many people make models. When we think about math class, we make models all the time in math class. It's something that we use to help us understand something that might be a little bit difficult at first. And when we make models, we have to analyze them. By analyzing models, we're examining them carefully to see if they work, to make sure that they're what we're looking for, and then we can go back and revise to change models, improve them if we notice they're not working the way that we'd like them to. When we work with others, it's called collaboration. And when we collaborate, we usually have to come to a consensus, which can be kind of hard sometimes. When we come to a consensus, we're making sure that everyone agrees with one another. Phase changes. We know that there's three main phases that different materials go through. They're solid, liquid, and gas. When we talk about phase changes, that's when something goes from one state to another. So when I think about freezing, I know that things freeze when they start as a liquid and then they become a solid based on cooling. When I think of melting, I think of a liquid when I think of melting, I think of a solid that becomes a liquid based on heating. When I take an ice tray out of the freezer and I leave it on the counter, it's going to melt. It has the room temperature heat hitting it that's going to cause it to melt. When I think of condensation, condensation is when gas turns back into a liquid. A good example of this would be when you get out of the shower and your mirror is fogged over, or when you're on the school bus in the morning and you can't see out your windows. That's condensation. And then there's evaporation, which is when we know that we can take a liquid and we can heat it up and it becomes a gas. When we think about concentration, we know that concentration is the ratio of solute to solvent in a solution. It's the ratio of salt to water in salt water. That could be a good example we could talk about. So if something is concentrated, it has a lot of solute in it. So in salt water, it would be salt water that has a lot of salt in it. And when something is dilute, it does not have as much solute in it. That could be an example when we didn't put as much salt in our water. In order to find concentration using a scale, we have to have three things. We have to use equal volumes of the two solutions we're comparing, as well as we have to have the same solute and the same solvent in order to get accurate representation. As for density, density is mass per unit volume. And if you remember, we learned that if something is more dense, it is also more concentrated. That's a really easy way to tell if something is more dense or less dense. Because if something more dense is more concentrated, then something that is less dense would be less concentrated. Last but not least, with density, we talked about layering. When we know that when we can layer substances based on their densities and they'll separate. When we layer things based on their densities, we want the most dense thing to go first into our cup or container that we're putting it in. So we want to make sure that the thing with the highest density or the most concentration goes on the bottom, and then we would layer in order on top of that. A saturated solution is what we just talked about in class. A saturated solution is when a solution where the solvent cannot dissolve any more solute. So when you think of the salt water that we made in our lab, we got to the point that no more salt would dissolve in the bottle with the water. And then we had to filter it out to find out how much how much salt we needed to saturate that solution. So a saturated solution is a solution where a solvent cannot dissolve any more solute. Just like how our water could not dissolve any more salt.